Kumar. So now I'm going to explain an infinite series. So the series is times half x squared times half plus x times 1/3 plus x times 1/4 plus x times 1/5 plus x and so on to infinity. So to solve this, first we've got to multiply all the x's to the other side of the equation. So now when I multiply this x over here, I get 1/5 plus x times 1/6 plus x. Well, I'm just increasing this format, so times 1/7 plus x and so on. So when I multiply this x over here, I get 1/5 plus x times 1/6 plus, the next is going to be x over 7 plus, then when I multiply this with the other one, it's going to be x over 8. So when I multiply with this x, I get x squared divided by 8. So then so now when I multiply this x, I get 1/5 plus x divided by 6 plus x squared divided by 7 plus x cubed divided by 3. So x cubed divided by 8. So this is our first step. We've got to multiply all the x's on the right side of this equation. So let me just work this. So when I multiply x over here, I get x squared times half plus x times 1/3 plus x times 1/4 plus x times, then it's going to be 1/5 plus x divided by 6 plus x squared divided by 7 and so on. So then we've got to multiply the other x, so x squared times half plus x times 1/3 plus x times, now this one, so it gives me 1/4 plus x over 5 plus x squared over 6 plus x cubed over 7 and so on. Right. So if I just continue doing this process, I get a good value. So it's x squared. Then when I multiply this with this, I get x divided by 4. Then x squared divided by 5. X cubed divided by 6. So let me just write this. So x squared times half plus x times 1/3 plus x over 4 plus x squared over 5 plus x cubed over 6 and so on. So now again we get x squared times half plus x over 3 plus x squared by 4 plus x cubed over 5 and so on. So when I multiply this x with this, well, I get x squared over 2 plus x cubed over 3 plus x to the power 4 divided by 4 and so on. So now what we've got to do is that we got to use the rules of integration. So if I take integral of x to the power n dx, now I could write it as x to the power n plus 1 over n plus 1. So if you look at this and hold all of these series, they look a bit similar. So I could write this x squared divided by 2 as, integral of x dx. So it's to the power of 1, so that's integral of 2 divided by 2. So, well, this is equal to integral of x dx. So when I do it for all these series, I get integral of x dx plus integral of x squared dx and so on. So then that's the integral of x dx plus integral of this x squared dx plus integral of x cubed dx and so on. So, well, if I take the integral common, I get integral of x plus x squared plus x cubed and so on. Well, you've got to put dx. It's a rule actually. So when I solve this one, I could integrate it and get a good value. So when I solve this, x plus x squared plus x cubed and so on, well, that equals, let's just keep it as y. Now if I take x common in this full sequence, I get x1 plus x squared plus x cubed and so on. So that equals to y. Right. So now if we look at this series, this is the same as this. So I could rewrite this one like that. So So this is the same as y, so x times 1 plus of y equals y. So when I multiply this x on this one, I get x plus xy equals y. So what I've got to do is that I've just transport it there. So this is adding, so when it goes to the other side of the equal to symbol, well, it subtracts. So x equals y minus xy. Well, now if I take y common, I could solve this equation. So 1 minus of x, then y equals x over 1 minus of x. Now we got it. So when we integrate that x plus x squared plus x cubed and so on, well, this is the same as y. We know that. So when I just integrate x divided by 1 minus x dx, I get the answer. But this is not a final step. We gotta do something else. So what I'm going to do is that partial fractions, I'm just going to conjugate on the both numerator and denominator. So that's the integral of x divided by 1 minus x. So when I conjugate it, it's times 1 plus x and times 1 plus x. Alright, so dx. When I multiply this over that, well, I'll just keep it just like this. So integral of x squared plus x divided by 1 minus x times 1 plus x dx. So when I'm going to use the partial fractions, well, I've got to take a divided by 1 minus of x plus b divided by 1 plus x equals x squared plus x divided by 1 minus x times 1 plus x. So we've got to just find the a and b values. So what I'm going to do is that, well, I'll just take the LCM, not the LCM, but I'll just multiply these two, and the denominator gets cancelled on both sides. Then I'll just use x equals something, a value, then find a and b. So when I use the cross multiplication, this over that and that over this, well, I get a times 1 plus x plus b times 1 minus of x divided by, so I've got to just multiply these two. Well, these two are the same like this. So 1 minus of x times 1 plus x equals x squared plus x divided by 1 minus x times 1 plus x. So we've got to just cancel. Right, so if I take x equals something like 1, well, 1 minus 1 equals 0. So when I take 0 times b, it's not even 0. So this equals 0. So we could just find the value of a. So x equals 1. X equals 1. So that's a times 1 plus 1 is 2. Then b times 1 minus of 1 is 0 equals, well, 1 squared is 1 and 1 is 1. So 2a equals 2, a equals 1. So we got the value for a. Now we've got to just solve for b. So we've got to solve for b. Now let x equal minus 1. So then when I add 1 minus of 1, well, I get 0. So that's not going to be an a. Well, I'll get a b, but so b times of 1 minus of minus 1, well, that is 1 plus 1 equals minus 1 to the whole squared plus 1 minus 1. So this equals 2, so 2b equals minus 1 plus 1, which is 0. So b equals 0 too. So when I just divide 2 on both sides, I get 0. So that's b, and that's a. Now what we're going to do is that interval of a times 1 plus x plus b times 1 minus of x divided by 1 plus x times 1 minus of x. Well, this is the same as this one when we integrate it. So when I substitute the value of a comma b, well, b equals 0. So that's not going to be an equation like this. So it's 0. So I'm just going to leave it just like that. So the interval of 1 times 1 plus x divided by 1 plus x times 1 minus of x. So we've got to just cancel these, and then we get interval of 1 over 1 minus of x, which is natural log of modulus of 1 minus x. So this is our answer. So x squared plus x squared times a half plus x times 1/3 plus x times 1/4 and so on equals natural log modulus of 1 minus x. So this is our answer. Thank you guys.